Look at this number 22. We're going to evaluate this integral right here, that expression from 1 to 4. Now, it's a quotient, so what I'm thinking here is I'm going to let u equal the denominator, right? It's going to be a u substitution. So we're going to let u equal the 3x squared plus x, and I'll circle it here. If I take that derivative, I'll get du dx. I know how these are going to work, right? We need du dx. That'll give us, what do we get here? 6x plus 1, and what do you know? There's that 6x plus 1. Multiply everything by dx. So du turns out to be the quantity 6x plus 1 dx. Now, we've got the u right down here, and then this expression here, what is that? There it is here. That's the du. Now, what I need to do before I go on and evaluate this is I need to get these in terms of u. Right now, even though we don't write it, it really is this. We're really going to x equals 1 to x equals 4, but now we're changing everything to u's, so I need these limits of integration in terms of u. So let's do this. We're going from x equals 1 to x equals 4, so let's start here. If x is equal to 1, what do we get for u? So what do you get? Well, here's u, right? U is right back in here. U is related to x. So now I'm saying x is 1. So what are we going to get here? 3 times 1 squared plus 1. So what do we get here? 4. All right, so if x is 1, u is 4. And then if x is 4, u is equal to, all right, so here's our u, right? Here's our u. Substitute 4 in there. We'll get 3 times 4 squared plus 4. So 16 times 3 is 48, 52. So now our new integral is this. We're going from 4 to 52 of, okay, we get 1 over u, and then the rest of this, the 6x plus 1 dx, that was du. So we recognize this as a natural log. So this is going to be the natural log. I'm just going to write an x because these are positive numbers, and if I write absolute value of a positive number is positive. So now this is going to give us, right, we're going from 4 to 52. So put in the upper limit, natural log of 52 minus natural log of 4. Now that's okay, but we can actually do better, right? I've got a difference of logs, so by the properties of logarithms, I can write it as a single log, the log of the first divided by the log of the second. And 52 divided by 4 happens to go nicely 13 times. So I'm going to get the natural log of 13. 23, we are going to integrate from 0 to 1 of, what have we got here? Quantity 3x plus 2 e to the 3x squared plus 4x, all that dx. Now, you know, these complicated ones we know will probably pop out if we make the right u substitution. And we have an exponential, and the suggested substitution would be let u equal the exponent. So let's give that a try. Let u equal that exponent. We'll get, let u equal the exponent, 3x squared plus 4x. I'll circle it so I can find it. Now we know what we need, du dx. Well, that's going to be 6x plus 4. I'm going to multiply by dx, so du is quantity 6x plus 4 dx. Now, this is what I have, 6x plus 4 dx. What are we looking for? Well, here's e to the u. We're looking for the 3x plus 2 dx. 3x plus 2, we've got 6x plus 4. But you can see that 6x plus 4 is just twice this. Why don't we, let's factor out a 2 here. We can factor out a 2. If we factor out a 2, it's going to look like this. du will be 2 times 3x plus 2 dx, and that's what we want right there. So let's divide by that 2. Divide by 2, and we'll get that 3x plus 2 dx is the 1/2 du. So we've made a lot of progress. What we have here now is e to the u And then this right here, the 3x plus 2 dx, that's 1/2 du. But these limits of integration, these are in terms of x, right? These are x's, even though we don't write them. Those are x's. So let's get them in terms of u. We'll say this. If x is equal to 0, u is equal to, all right, well, here's our u right here, right? Here's our u. All right, so I'm going to put the 0 in here. Now, you can see if you put 0 here and 0 here, the whole thing is going to collapse to 0. So if x is 0, u is 0. If x is equal to 1, u is equal to, all right, 3 times 1 squared plus 4 times 1, u is equal to, I'm thinking 7. So here's our integral. We're going to go from u equals 0 to 7 of e to the u times, that was the 1/2 du. So now this is going to give us 1/2. The integral of e to the u is e to the u, and we're going from 0 to 7. So this is going to give us 1/2 e to the 7th minus 1/2 e to the 0. E to the 0, of course, being 1. So what we're going to get here is 1/2 e to the 7th minus 1/2 times 1 is just 1/2. That's probably okay, or I can factor out the 1/2, getting 1/2 times the quantity e to the 7 minus 1.